All right, guys, we are working on finishing up the basics of trig and we're getting to the applications. So I need you to find your packet. We're going to do worksheet 6B and a couple questions off 7A and 7B. So I need you to maybe pause the video till everybody's ready to do the notes on angles of elevation and depression. So the angle of elevation is always from a horizontal line up. Horizontal being like you're looking at the horizon straight across this way, okay? Now the trick is that angle of depression is from a horizontal line down, okay? So what happens is that when they give you an angle of elevation or depression, you're going to kind of think of it like this. It's alternate interior angles. This one's elevation, and this one up here would be depression, and they're equal. So it doesn't matter which one they give you, they're going to be equal. The thing you can't do is make anything with a vertical line. So if they give you an angle of depression, it's not in here. And if they give you an angle of elevation, it's never like this. It's never with a vertical line, okay? This being vertical here and here. So you have to make it with a horizontal line. So let's do some examples. This one shows an angle of elevation up of 20 degrees. Now, that means the people on the ship are looking up at the jet 20 degrees, but from the horizon instead of looking straight. The jet pilot, instead of looking straight out, would look down the same 20 degrees. They are equal because they're alternate interior angles like this, okay? But what we're supposed to find here, I'm going to go with, if one of them decides to shoot a missile at the other, how far does it have to travel here along the horizon? Or, along the hypotenuse. So, if we use this triangle down here on the bottom, we're going to work from this angle. So I'll put my little smiley face over here. This would be a leg and this would be a leg. This would be adjacent, which we know nothing about. But this opposite leg is 10,000 feet, and we're trying to find the hypotenuse. So we're going to say, let's see, O and H would be sine of 20 degrees equals opposite over hypotenuse. Now, if we cross multiply, we get 10,000 equals x times the sine of 20, which is some number that we're going to get on the calculator. So we're going to divide that off. And we're going to type this into our calculator, which I don't have open, making sure we're in degree mode. All right, so up at the top, it says degrees up here, so I think we're golden. We're going to type 10,000 divided by sine of 20. Make sure you get all those zeros in. 4 zeros. Divided by the sine of 20. Make sure you hit the right one. And they have 29,238 feet the missile would have to travel. Hope I remembered that number right. Okay. Pause the video as often as you need. I'm just going to keep going though. All right. This one says we have a fire hydrant. A fire hydrant sits 72 feet away from the base of a 125-foot tall building. So this is our building, and it is 125 feet tall. And we're supposed to find out, here's the fire hydrant. Okay, I don't even know what that is. Pretend it's a fire hydrant. and we're supposed to figure out the angle of elevation, which would be here looking up. So because we're finding an angle, we're going to use second something. In this case, the two that make the right angle are the legs. Here, this would be the opposite, and this would be adjacent. And TOA uses opposite and adjacent, so we're going to say the tangent of angle x equals 125 over 72, opposite over adjacent. And then remember, when we're solving for an angle, we have to use that second button, and then tan will bring the little -1, and we're going to type 125 over 72, and that's going to tell us how big the angle of elevation is. So we're doing second tan 125 divided by 72, 60 degrees roughly. So if there's a puppy dog gonna take a bathroom break on that fire hydrant, he's got to look up 60 degrees to see the top of the building over there. All right, number 13 is an angle of depression question. I can't draw, guys. Okay, so here's the beach over here. People are laying out on their towels. Okay, and here's the water, and this guy's out here, and he's up on a big wave. That's a wave, okay? So he's on his surfboard up here. Okay, really bad drawer. The angle of depression from the surfer to the shore is 10 degrees. Now, where does the 10 degrees go? Remember, it's got to be from the horizon straight out down. Okay, that's not a very straight line, but 10 degrees is there. So if we draw this triangle in, the 90 is down here, and if we use alternate interior angles, pretending that I can draw parallel lines, this would also be 10-degree angle of elevation for him to look up. All right, the wave is 7 feet tall, and we're trying to find the distance from the surfer to the shoreline. I'm not really sure which they wanted us to find. I'm going to go with they want the direct distance here. Hopefully on a quiz I would give you a little bit of a picture, or I would be clearer about that. But from where he is at the top of the wave to where he's going to crash onto the shore, we're going to find that distance. So from the angle over here, we know the opposite leg, and we're looking for the hypotenuse. Now, opposite and hypotenuse is SOA. So we're going to say the sine of 10 degrees equals 7 over x. Now, some of you know this is the kind where we're going to have to divide because the x is in the denominator. I'll show why that is. If you cross multiply going this way, you just get 7. If you cross multiply this way, you get x times the sine of 10. And then we have to divide by the sine of 10 to get the x by itself. So if I type 7 divided by the sine of 10, I get 40 degrees roughly. Nope, 40 feet, just kidding. So it was 40 point something, wasn't it? 40.3. And it's feet away from the shoreline. All right. We're going to do 1 or 2 more angle of elevation questions off 7A. And I'm going to go kind of quick here. It totally doesn't matter. Oh, number 4 is a little tricky. All right. So we'll do maybe 3 or 2 and 4. How's that sound? 2 says a 30-foot ladder. So the ladder is 30 feet right here. Forms a 50-degree angle with the ground, so the ladder to the ground is 50 degrees. When placed against a brick wall, how far up the wall, so we're trying to figure out this distance here, will the ladder reach? All right, so from our angle, we are looking for the opposite, and we know the hypotenuse. So again, sine of 50 degrees equals x over 30, opposite over hypotenuse. So from the 50, we have the opposite is x and the hypotenuse is 30. We set it up. And then if we cross multiply, these are right across from each other. So we just get to type 30 sine of 50 and we're done. So if I go to the calculator, 30 times the sine of 50, I get basically 23 feet, yes. So the ladder will reach about 23 feet up. All right, you may need to pause if people need more time, but I'm jumping down to number 4. This one is a little bit trickier. I'm not sure I assigned these on the worksheet, but it says Michael, whose eyes are 5 feet off the ground, so he's already 5 feet up, is standing 30 feet away from the base of the building. So this is 30, which would make this 30 because there's a little rectangle down here. He has to look up 50 degrees. So again, angle of elevation looking up right in here to a point on the top of the roof. How tall is the building? All right, so we're trying to find this distance, but when we find that blue distance right there, we're gonna have to add on this little 5 feet down here for his height. So x is gonna be called opposite of the angle, and this 30 feet down here is adjacent, so that would be tangent, TOA. The tangent of 50 degrees equals x opposite over 30 feet adjacent. Then because they're across, we can just multiply 30 times the tangent of 50. Thirty times tan 50 is 35.75 or roughly 35.8 feet. But that's this part of the building, the blue part, okay? So to find the entire height of the building, we need to add the additional little 5 feet of his eyeballs that were above the ground by 5 feet. So it's almost a 41-foot tall building. That would probably be about a 4-story building. All right. Do a couple angle of depression questions and then we're good to go. So I'm on the back, worksheet 7B. It says a little boy standing on a cliff above the water and sees a boat that is 200 feet away from the base. Okay, so the 200 feet is the base of the cliff to the boat. It is 350, the boat is 350 feet away from him. What is the angle of depression? So the 315 feet is if he were to, throw a rope out to them, would have to be 315 feet long. It wants to know the angle of depression. This is the actual angle of depression, but remember, oh, sorry, I used a theta. We do that in trig all the time, and your teachers might use theta, but I'll use x. So the angle down here is going to be the same by alternate interior angles, so we could find either one. If we use this little triangle down here that I've drawn, next to the x would be this, so this is an adjacent 200. This is the hypotenuse. Adjacent and hypotenuse would be ka. So we have cosine of x degrees equals adjacent over hypotenuse. So when we're looking for an angle, that's when we do that second thing. 200 over 315. Again, it's, maybe I can make this bigger so sure you can see it. Second cosine. All right, and then I always forget the numbers. It was 200 over 315. So I have 50.6 degrees. Angle of depression is about 51 degrees. 50.6 is fine, I just rounded. All right, one more question. All right, maybe I'll do 7, I don't know. It says, from an airplane at an altitude of 1,200 meters. So 1,200 meters is his flying height straight above the ground. The angle of depression to a building on the ground is 28 degrees. So we're going to measure the 28 degrees always from the horizontal. So it goes here, which would mean by alternate interior, we can also put it here. It says, find the measure of the distance from the plane to the base of the building. So they want us to find from the plane to the base of the building. So where the plane actually is. So we're going to do, this is a hypotenuse that we're looking for. From this 28 degree angle, this would be the opposite side. Hypotenuse and opposite is sine again. So we have the sine of 28 degrees equals opposite over hypotenuse, which is x. So if we cross multiply, we get 1,200, or some of you know we're just going to need to divide. And we'd have, going this way, x times the sine of 28, which is some number that we're going to get on the calculator. So to get it away from the x, we're going to divide it. So I have 1,200 divided by, sorry, not times, the sine of 28. So 1,200 divided by the sine of 28 is 2,556 meters from the building, the base of the building. All right, well, I hope this short video will help you do the little worksheet on angles of elevation and depression. And I ask only that if I made a mistake here, you help each other figure it out and then help each other get the worksheet done. You can work together as far as I'm concerned. I just want you to turn something in. Thanks. I'll see you on Tuesday or Wednesday next week, which day is the A or B day. Have a good one.